Berlin, March the 17th, 1945, 2:47 a.m. The bunker beneath Tempelhof Airport hummed with the electric whisper of German ingenuity in the dim blue glow of cathode ray tubes, Obergefreiter. Wilhelm Schröder sat hunched over his Würzburg-Riese radar console, watching green phosphorescent blips dance across the circular screen like fireflies trapped in glass. The air smelled of ozone and stale cigarette smoke, cut with the acrid tang of overheated vacuum tubes. Outside, the city slept fitfully between air raids. Inside this concrete tomb, Schröder and his team maintained their eternal vigil, eyes fixed on screens that showed them a world invisible to human sight, a world of electromagnetic echoes bouncing off metal wings in the darkness above the Reich. But on this particular night, something was wrong. The screen showed contacts, dozens of them, appearing and disappearing in patterns that made no sense. They materialized out of empty air over the eastern districts, drifted southward through zones where no aircraft could possibly fly, then vanished as mysteriously as they had appeared. Schröder adjusted the gain control, checked the magnetron, verified the antenna rotation. The equipment functioned perfectly, yet the ghosts remained, impossible and undeniable, mocking everything he had been taught about the precision of German technology. He reached for his logbook with trembling fingers and began to write. Unidentified returns, multiple bogies, behavior inconsistent with known aircraft, possible equipment malfunction, possible... He paused, pen hovering over the page. Possible what? That the laws of physics themselves had turned against the fatherland? This was not the war Wilhelm Schröder had been promised. The story of radar in the Second World War is often told as a tale of British innovation and American mass production, the chain home stations guarding England's coast, the cavity magnetron shared across the Atlantic, the airborne intercept sets that turned the tide of the nocturnal bombing campaign. But Germany possessed its own sophisticated radar network, born from the same theoretical breakthroughs in radio wave propagation that had revolutionized electronic warfare across all combatant nations. The Würzburg radar, in its various configurations, represented one of the most elegant engineering solutions of the entire conflict. A parabolic dish system capable of tracking individual aircraft with remarkable precision, guiding night fighters to their prey and directing flak batteries with mathematical accuracy. By 1945, however, the German radar network existed in a state of technological paradox. The equipment itself remained superb, perhaps even superior in certain respects, to equivalent Allied systems. German radar operators were extensively trained, their technical education thorough and methodical. Yet they found themselves detecting phantoms, chasing shadows, watching their screens fill with false returns that defied explanation. The ghosts over Berlin were real, real enough to show on multiple sets, real enough to be logged and reported, real enough to send night fighters scrambling into empty sky while actual bomber streams slipped through the darkness unmolested. Wilhelm Schröder had joined the Luftwaffe in 1941 at the age of 19, drawn by the promise of serving in a technical role that would keep him away from the meat grinder of the Eastern Front. He possessed an aptitude for mathematics and had shown interest in wireless radio as a civilian. The Luftwaffe needed radar operators, and radar operators needed men who could think in terms of wavelengths and propagation angles. He was sent to a training facility outside Munich, where instructors with engineering degrees taught him to see the world as a geometry of radio waves, to understand that every metal object above a certain size created an echo, that the strength and character of that echo revealed altitude and distance, that skilled operators could distinguish between friend and enemy by the pattern of returns alone. They told him he was part of an invisible shield protecting the Reich, that German radar technology would detect every enemy bomber long before it reached the target. that the accuracy of their systems gave the fatherland an insurmountable advantage in the battle for air superiority. They showed him reports of successful intercepts, of British bombers shot down because radar had betrayed their position, of the night fighter pilots who called radar operators their guardian angels. He believed it all. Why wouldn't he? The equipment was magnificent, the training rigorous, the logic inescapable. Radio waves did not lie. Mathematics did not harbor doubt. The screen showed truth, and truth would preserve Germany. The reality revealed itself gradually, like a photograph developing in chemical bath. The first anomalies appeared in late 1943, isolated incidents that could be attributed to equipment glitches or atmospheric interference, contacts that accelerated impossibly fast, returns from altitudes where no aircraft could maintain flight, radar signatures that split into multiple targets or merged into single contacts for no apparent reason. Schröder and his fellow operators dutifully logged these anomalies, reported them through channels, adjusted and calibrated their equipment. Sometimes the ghosts disappeared, more often they multiplied. By the winter of 1944, the phantom signals had become a nightly occurrence. Allied bomber streams had learned to protect themselves with what the operators came to recognize as deliberate electronic warfare, though at first they lacked even the vocabulary to describe what they were experiencing. The term Duppel, the German name for what the British called window and the Americans called chaff, entered their lexicon that year. Millions of thin aluminum strips, cut to specific lengths corresponding to German radar, wavelengths, dropped in clouds from Allied bombers to create false returns that bloomed across radar screens like metallic snowstorms. Each strip acted as a tiny radar reflector, and collectively they could render an entire radar network temporarily blind, filling screens with so much clutter that real bomber formations vanished into the electronic noise. But the ghosts that haunted Berlin's radar operators in the final months of the war went beyond simple chaff. They encountered what would later be identified as moonshine repeater systems, airborne transmitters that received German radar pulses and rebroadcast them with amplification, creating the signature of entire bomber formations where only single aircraft actually flew. They detected mandrel jamming, powerful transmitters that flooded specific radar frequencies with noise, turning carefully calibrated receivers into useless static generators. They watched carpet jammers create false altitude readings, sending night fighters climbing or diving to pursue targets that existed at entirely different heights than the radar indicated. Each new countermeasure represented a technological leapfrog, an escalation in the invisible war being fought in the electromagnetic spectrum, and each one revealed to operators like Wilhelm Schröder a disturbing truth. The enemy possessed resources to waste. The amount of aluminum required to produce effective chaff was enormous, tons of it scattered across German airspace every night. Metal that could have been used for aircraft construction or ammunition production, instead deployed as disposable decoys. The power requirements for effective jamming demanded generators and transmitters whose weight and bulk reduced bomber payload capacity. The development of these countermeasures required research facilities, testing programs, manufacturing capability, entire industrial ecosystems devoted to the single purpose of overwhelming German radar defenses. Schröder had grown up in a Germany that spoke constantly of Lebensraum, of the need to conquer territory because the fatherland lacked resources, lacked space, lacked the material abundance necessary for greatness. Yet here was the evidence of enemy abundance rendered visible on his radar screen. Wealth so profound that the Americans and British could afford to turn thousands of tons of aluminum into single-use interference devices, could power transmitters whose sole function was to create electromagnetic noise, could dedicate entire aircraft squadrons to the mission of electronic deception rather than direct combat. The symbolic weight of the chaff haunted him. Those thin strips of aluminum fluttering down through the night sky over Berlin represented something more than tactical cleverness. They were a kind of message, as clear as any propaganda broadcast. We have so much that we can throw it away. We can fill your sky with our excess. As the war ground toward its conclusion, Schröder's logbook became a chronicle of electronic chaos. Entries from February 1945 recorded nights when the radar screens showed nothing but clutter, when operators simply gave up trying to distinguish real contacts from false ones, when the entire early warning network effectively ceased to function. Other entries described the opposite phenomenon, nights of perfect clarity when no Allied aircraft appeared at all, when the screens remained empty for hours, only for bomb damage reports to reveal that formations had somehow reached the city center undetected, flying through gaps in coverage that shouldn't have existed according to the official network maps. He began to understand that the gaps were deliberate, that Allied intelligence had somehow mapped the German radar network with sufficient precision to identify dead zones and exploitation corridors. The shield, he had been told, was impenetrable, had always been full of holes. The enemy had simply taken the time to find them. German radar technology wasn't inferior. In some respects, it remained world-class until the war's end. But German radar coverage suffered from a fatal weakness that no amount of technical sophistication could overcome. The network was static, fixed, predictable. Stations couldn't be easily moved or redeployed. Once the Allies understood the positions and capabilities of German radar sites, they could plan routes around them or develop specific countermeasures tailored to each installation's frequency and power signature. The Würzburg radar, as sitting in its bunker beneath Tempelhof Airport, with its elegant parabolic dish and precision tracking mechanism, had become a symbol of Germany's strategic blindness, magnificent engineering deployed in service of a cause that had already lost: the war of resources, the war of industrial production, the war of mathematical inevitability. Every night, Schröder watched this reality play out in green phosphorescence on his circular screen. In the final weeks before Berlin's fall, discipline in the radar bunkers began to fray. Some operators continued their duties with mechanical precision, logging ghost signals and real contacts with equal diligence, as if maintaining proper paperwork might somehow alter the outcome. Others grew fatalistic, drinking ersatz coffee laced with contraband schnapps, making sardonic jokes about the Amis and their infinite aluminum supply. A few simply stopped showing up, deserting their posts to seek out families or disappear into the chaos of the collapsing Reich. Schröder kept working. Not from ideology, the propaganda slogans that had once stirred his young heart now rang hollow in his memory, but from a strange curiosity that had replaced his earlier certainty. He wanted to see how the story ended, wanted to witness the final act of this technological drama. The ghosts on his screen had become familiar companions, their impossible behavior almost comforting in its consistency. Real contacts moved according to the laws of physics. The ghosts obeyed only the logic of electronic warfare. In a city where reality itself seemed to be disintegrating, where buildings he had known since childhood vanished overnight in firestorms, where the radio broadcast increasingly obvious lies about victory and counteroffensives, the ghosts at least were honest. They announced their nature through their impossibility. On April 22, 1945, Soviet artillery began shelling Berlin from positions east of the city. The sound reached even into the underground bunker, distant thunder that made the concrete walls vibrate, that jarred the cathode ray tubes and created momentary static bursts on the radar displays. Schröder's radar station received orders to begin tracking Soviet aircraft, to redirect the night fighter control network toward the new threat. But the Würzburg had been oriented westward for years, positioned and optimized to detect British and American bombers approaching from those directions. Turning it to face east meant operating outside its ideal parameters, picking up ground clutter from the suburbs, dealing with the electromagnetic interference of the ongoing artillery barrage. That night, the screen filled with contacts, hundreds of them, far too many to count or categorize. Some were undoubtedly real aircraft, Soviet ground attack planes supporting the final assault, German transport aircraft attempting to evacuate important personnel, perhaps the last handful of Luftwaffe fighters still capable of flight. But many others were phantoms of various origins, false returns from exploding shells, ground vehicles misidentified as low-flying aircraft, reflections bouncing off the burning city itself. The electromagnetic spectrum over Berlin had become a chaos of overlapping signals, a radio tempest that rendered sophisticated radar equipment nearly useless. Schröder continued tracking and logging, his hand moving across the page with the automatic precision of thousands of hours of training, recording data that he knew would never be analyzed, would never inform any tactical decision, would perhaps never even be read. The act of documentation had become its own purpose, a way of maintaining structure as everything else dissolved. In the early morning hours of May 2, 1945, Berlin officially surrendered. The radar station beneath Tempelhof received no formal orders to cease operations. Communication with higher commands had broken down days earlier. Soviet soldiers found the bunker later that morning, found Wilhelm Schröder still at his post, still watching his screen, though by then the power grid had failed and the Würzburg stood dark and silent. They confiscated his logbook, along with all the station's technical documentation, material that would eventually make its way east to Soviet research facilities where captured German radar technology would be studied and reverse-engineered. Schröder spent the next 3 years in a prisoner-of-war camp, returning to a Germany that existed in a state he could never have imagined in 1941. He found work, eventually, putting his technical knowledge to use in civilian radio and eventually in the emerging television industry. He never spoke much about his war service, never discussed the ghosts he had tracked across Berlin's night sky. But in the late 1970s, contacted by a young historian researching the electronic warfare campaign over Germany, he agreed to an interview. The transcript of that interview reveals a man still trying to reconcile what he had believed with what he had witnessed. He described the Würzburg radar with obvious professional pride. It had been, he insisted, an excellent piece of equipment, well designed and reliable. He spoke respectfully of his training, of the instructors who had taught him his trade. But when asked about the effectiveness of Germany's radar network in the war's final years, his answer came halting and measured. We could see them coming. That was never the problem. We could see everything, the real bombers and all the tricks they used to confuse us. The problem was that seeing them made no difference. We lacked the fighters to intercept, lacked the fuel to send up the fighters we did have, lacked the pilots to fly them even when fuel could be found. And even if we'd had all those things, they would have simply brought more bombers, dropped more chaff, transmitted more jamming signals. They had more of everything, the ghosts on our screens, all those false contacts and electronic deceptions. They weren't really about blinding us. They were about showing us that they could afford to blind us, that they had resources to spare for such things while we were running out of everything. The historian asked if Schröder had felt betrayed by the promises made to him during training, by the assurances of German technological superiority. The old man considered the question for a long moment before answering. Betrayed? No. Deceived, perhaps. We were very good at building machines, at solving technical problems with elegant engineering solutions, but we confused technical sophistication with strategic wisdom. A perfect radar that cannot be acted upon is no better than a broken one. A brilliant interceptor with no fuel is just an expensive sculpture. We were trained to see the world in terms of wavelengths and equations, and those tools work beautifully for solving certain kinds of problems. But war isn't a problem in electromagnetics. It's a problem in resources, in production, in industrial capacity. We could calculate the radar cross-section of a B-17 with extraordinary precision, but we couldn't calculate that America would eventually build tens of thousands of them. In the decades since the war's end, the story of Allied electronic warfare against Germany has been well documented. Historians have catalogued the development of chaff and jamming systems, have traced the escalating technological competition between radar and countermeasures, have interviewed participants from both sides of this invisible battle. What emerges from these accounts is a picture of American and British abundance deployed with calculated purpose, not merely wealth for its own sake, but wealth transformed into tactical advantage through systematic application. The tonnage of chaff dropped over Germany during the war years exceeded 20,000 tons. Aluminum that could have built thousands of fighters instead cut into precisely sized strips and scattered to the wind. The electrical power consumed by Allied jamming transmitters during a major raid rivaled the output of small power stations. The research effort behind these countermeasures involved some of the finest scientific minds of the generation, pulled away from other potentially valuable work to focus on the narrow problem of overwhelming enemy radar. This represented a fundamentally different approach to warfare than the one Germany had adopted. The Reich fought a war of engineering elegance, seeking victory through technical superiority and tactical brilliance, always conscious that resources were limited and therefore must be carefully allocated to the most efficient solutions. The Allies, particularly the Americans, fought a war of overwhelming material abundance, accepting inefficiency and waste as acceptable costs if they contributed to certain victory. A German engineer might design a magnificent radar that could track targets with exceptional precision while consuming minimal power. An American engineer might design a cruder system that used 3 times as much power but could be manufactured in 1/3 the time using semi-skilled labor and standardized components. Over the duration of a long war, the American approach proved decisive. The ghosts that Wilhelm Schröder tracked across his radar screen were manifestations of this strategic reality. Each false contact represented resources deployed not for direct destruction, but for confusion and deception, a luxury that only the materially abundant could afford. The Reich allocated aluminum to build aircraft. The Allies allocated aluminum to build aircraft and to render enemy radar unreliable. That difference, multiplied across thousands of nights and hundreds of radar stations, helped define the war's outcome. There's a broader truth embedded in this story, one that extends beyond the specific technical details of radar and countermeasures. Totalitarian systems tend to emphasize quality over quantity, to celebrate engineering excellence and technical sophistication, because these achievements can be controlled and directed by centralized authority. They make for compelling propaganda, the brilliant weapon, the invincible machine, the triumph of will and design over crude numerical advantage. Democratic industrial states, conversely, tend to emphasize mass production and overwhelming material superiority, not because their engineers lack sophistication, but because their economic systems optimize for output rather than elegance. The American way of war in the Second World War was often wasteful, sometimes crude, occasionally inefficient, but it was inexhaustible. The radar operators in bunkers beneath Berlin learned this lesson through the evidence of their own screens, watched it play out in green phosphorescence night after night, saw the proof accumulating in their logbooks. The enemy had resources to throw away, could afford to fill the sky with metallic chaff that would flutter down like rain and serve no purpose except to create electronic noise. This abundance was itself a weapon, perhaps the most devastating one in the Allied arsenal, because it made eventual defeat mathematically certain regardless of courage or skill or technical sophistication. Wilhelm Schröder died in 1992, having lived long enough to see German reunification, to witness the end of the Cold War that his logbook had inadvertently contributed to when Soviet intelligence studied captured German radar documentation. In his final years, he occasionally reflected on his war service with the perspective that only decades can provide. He told his grandchildren when they asked about the war that he had spent those years watching ghosts, that he had sat in a bunker beneath an airport and tracked signals that weren't always there, chasing echoes through a darkness that technology had made visible but couldn't illuminate. The aluminum strips that once fell over Berlin have long since corroded into dust. The Würzburg radar that Schröder operated was probably dismantled for scrap metal in the reconstruction years, its elegant parabolic dish cut apart, its precision mechanism salvaged for components. The bunker beneath Tempelhof may still exist, buried under layers of subsequent construction, or it may have been filled in and forgotten. But the lesson encoded in those phantom signals remains relevant, a reminder that in total war, abundance defeats efficiency, that the capacity to waste resources becomes its own form of military power, that even the most sophisticated technology becomes obsolete when the enemy can afford to overwhelm it through sheer material superiority. The ghosts were real, in their way. They showed Wilhelm Schröder a truth that ideology had hidden from him, that the war had been lost not in some decisive battle or strategic blunder, but in the economic calculations that determined one side could afford to fill the sky with decoys, while the other could barely afford to fuel its interceptors. He spent the rest of his life processing that revelation, trying to reconcile the excellence of German engineering with the inevitability of German defeat, understanding finally that the two were never contradictory, that you can build perfect machines and still lose if your opponent can build adequate machines in such quantities that perfection becomes irrelevant. In the end, the phantom echoes over Berlin were not technical malfunctions or equipment failures. They were signals from the future, announcing the post-war world where American industrial abundance would define global power, where material wealth would prove more decisive than technical sophistication, where the capacity to produce and consume and, yes, to waste would become markers of ideological victory. The ghosts showed Schröder this future before it arrived. He watched it approach on his circular screen, contact by impossible contact night after night, until the mathematics of abundance could no longer be denied, and the Reich itself became just another phantom signal fading from history's display.